Alright, so in this module I'm going to be talking about the general guidelines for analysis and test selection. So after you've gotten your data for your project, here's where we're going to talk a little bit about more what you should be doing with that. So this is where we're going to apply all the things that we've been doing with Cingwin and everything that we've learned about graph interpretation. The very first step is just to perform a visual analysis of your data. So in Cingwin, pulling up a graph of the baseline intervention and trying to figure out if there's any kind of trends or anything that you've noticed about the four properties of graph data: level, stability, trend, deterioration, improvement, stability. So the visual analysis based on the four properties, and then following the guidelines on either the left-hand side if there's variable data, or on the right-hand side if there's a linear trend. So let me show you an example of that. So from these examples from Lecture 9, you can see that there's not really a trend in either one of these. So on the left-hand side, there's stability, no trend, just flat. And on the right-hand side, you can also see that there's no real trend here. It's really variable. So in either one of these situations, you would follow the left-hand column for those steps. But if you had something like this going on in your intervention stage where you can clearly see a trend, or in this slide where you clearly see a trend, then you would follow along the right-hand side for your data interpretation. So back to this paper, here's what I want you to do once you've got your results and once you've taken a look at your data. And again, I just should clarify before you even start that the purpose of this isn't to prove that you're an awesome interventionist or that your single system design was really great to reach the outcomes that you're shooting for. It's more of showing me that you understand what to do with this and how you understand the interpretation and analysis of your data. So again, I'm more concerned with the write-up and you being able to show that you're able to have clear justification for your analysis and that you understand the application of this. So let's start with the left-hand side. If you do have variable data, then remember we talked about inserting the mean line or reporting a measure of central tendency. So it says step 1 was the visual analysis. Step 2 is to compute and superimpose a mean line and report on the range. But remember, if you do have outliers, then you would report the median as opposed to the mean. So this is an example from the smoking cessation example that we did from the Cingwin activity. So here it's really simple to insert the mean line. All you have to do is click on Graphs, Central Tendency, and Mean. And then Cingwin inserts the mean line for you. So step 3 is to test for autocorrelation. So if you remember back to the first activity we did with Cingwin after data entry was the test of autocorrelation, and this is testing for the assumption of independence of observations. So we can test for that real simply in Cingwin as well. So if you'll remember, you click on Statistics, Autocorrelation, RF2, TF2, and you would test baseline and intervention for autocorrelation. In this example, the data was autocorrelated, so you'd have to do the moving transformation. So again, if your data is autocorrelated, you would click on Statistics, Transform Data, Moving Average, and then Baseline only, since the baseline is what was autocorrelated. And then you can see from your p-value that the data is no longer autocorrelated. And then you close this out again, and your data will be saved as trans.dbf, standing for transform data. So I'll open up that file. It's going to be under my C drive. And then Cingwin 32, Files, and if I scroll to the bottom, here it is, trans.dbf. So I'd open up that file, test for autocorrelation, and it's no longer autocorrelated. I should check the intervention phase, also not autocorrelated. So we've met our statistical assumptions for independence of observation. We don't need to do anything else here. So now we can continue to step 4. So here it says compute the 3 standard deviation band approach. Use the C-chart for count data and report whether or not there was statistical significance was achieved for the outcome of interest. So here I would go into graphs, SPC chart, C-chart, and baseline intervention. And so from our cigarette use chart, we can see that there were several days where they reached the level of statistical significance in reducing their cigarette smoking, because you can see that there were several days that were below the lower control limit. And so then after we finish step 4, step 4b is to compute the t-test, and then following up the t-test to the d-index. So I'll close this out and click statistics, t-test, intervention to baseline, and we can see that the p-value is below 0.05, so this is the level of statistical significance was reached. The reduction from baseline mean of 21.8 to an average of 8.5 during the intervention phase. And again, you'd also want to report the range here. And then lastly, you would click statistics, effect size, d-index, baseline to intervention, and you could see that the d-index was greater than 50% reduction in the amount of cigarettes that they were smoking on average. And then you could just follow my slides to look at the write-up of how to do this. Again, this is all going to be posted up on D2L. So if this is how your data looks, then it's should be pretty straightforward to write up the t-test and the 3 standard deviation band approach. But let's say there was a linear trend. So in the case that there was a linear trend, you would compute and superimpose the acceleration line. If your data looks something more like this, where you can see a trend, then reporting the mean line isn't really going to do your data any justice. Because if you insert a mean line, it's not really going to show what trend you noticed. So it makes a lot more sense to insert the acceleration line and have it look like this. So I'm going to go back to Singwin and open up our role play client from the acceleration line. So here's where we looked at the acceleration line, and we can definitely see a little bit of a trend here. So you can follow my slide on, or my video on acceleration lines, but I'll just show you a quick example of how to do this. So again, you'd click Graphs, Acceleration Line, Baseline to Intervention, and here's your acceleration line. So again, I would recommend looking up slides on how to write up the acceleration lines. I've got a few of them on D2L that you can look at. And again, you'd want to report on the descriptive statistics as well, range, change in average behavior. And then step 3 is to compute the d-index of effect size. So the same thing as with variable data. So again, you just click statistics, effect size, d-index, baseline to intervention. And then you would say that there was a 46.9% decrease in the operationally defined problem on average. And so again, just when thinking about writing these up and what you're going to put in your final project, don't feel a lot of pressure to put so many graphs. I would recommend copying out maybe 1 or 2 graphs, and then from there, just making sure that you've got a solid write-up and solid interpretation, because I'm a lot more interested in figuring out your comprehension of the data as opposed to you just giving me a lot of information. Because what's backfired on people in the past is just inserting 10 different graphs and not really reporting too much about why they chose those graphs or what their steps were in interpreting the data. So again, I'm a lot more interested in interpretation, and I would rather have 1 graph that was really well written than have 10 that didn't really have too much of an explanation, that were all out of context. So again, feel free to shoot me your data, your interpretations before submitting your final paper, and I'll be happy to give you any feedback on how I think you could improve, or how I think that you could do an improved job of interpreting your data or writing it up.